Let's continue looking at popnets by looking at how we can initialize our velocities. So as always, this project file will be available on Patreon. If you want to grab it, you can do so on there. But again, we're just inside of stage or stage context here, Solaris, and inside of a stop create. And in here, we want to start looking at how we can initialize our velocities on our particles. So again, we need some objects to spawn particles on. In this case, I'm going to use a sphere, and we'll drop down our popnet. I'll make sure we're on the first frame there. So with this, if I go ahead and I press play here, you can see that we don't have any sort of motion on our particles. That's because we don't have any forces that are acting on these particles. One of those forces that can be inherited from the geometry that you're inputting is going to be your velocities. So if I go ahead back to the start frame here, one way that we can add velocities to our object is going to be by using a point velocity node. So just by selecting this curl noise and selecting add curl noise, if I go ahead and actually look at our sphere here, if I bring up our visualizers and visualize our velocity, you can see that we have some velocities being added here. So we can play around with, our scale, our pulse duration, swirl size, whatever we want. If I go ahead and select our popnet, I'm going to just deselect our velocity vectors there so we're not visualizing those. If I press play, I'm going to turn on real time as well. You can see that we have our particles that are being shot out, and they now have some velocities that are being added to them. And part of that is because we have our velocities on our input object. The other part is if we dive in here and come to our pop source and come to our attributes, you can see that it says we have this initial velocity, and it is currently set to use inherited velocity. And we also have this inherit velocity. If I go ahead and set this to a value of 2 and I press play, you can see that they're shooting off a lot faster. If I set this to like 0.1, for example, you can see that this is acting as a multiplier for our velocities. So we can slow them down or increase them as needed with this inherit velocity multiplier. We also have some other options here. We can add to inherit velocity. And for this, I'm actually going to come back up here and I'm going to use something other than this point velocity. I'm just going to set them myself with an attribute wrangle. So I'll wire this in. And I'm just going to not do anything too fancy here. I'm just going to do v at v is equal to, and then set 0, 1, 0. And what this is going to do is just add a velocity going upwards. So if I press play, you can see we have some velocities going upwards. Let's go ahead and actually set this back to use inherited velocity. And you see that they're just going to be moving upward at a constant rate because we have that velocity set. Now, if I go ahead and set this back to add to inherited velocity, you already kind of saw what happens here. If I press play, they're kind of shooting off all over the place, but they're inheriting the velocity that we had, but they have this variance added to them. So if I set this to 0 on all of these, if I press play, you can see that they're just going to move up just at that constant rate. If I change this to a value of 1 for the variance, it's going to add somewhere between 0 and 1 in the y value. So some of them may have a value of 2 for their velocity in the y. Some of them may have a value of 1 or anywhere in between those. So we can add some variance with that. We can also add some velocity. So if I wanted to just overall make them faster, I could add 2 to their y velocity. You can see that now they're moving a lot faster. Or if I wanted to add some in the x there, you can see if I press play that we have some movement kind of diagonally because of the velocities that we're adding. And again, we can just add in some variance to this, to all three, and we can get some variance in all directions. So that's one way you can get sort of like a fire hose type of an effect if you wanted to go about it this way. I wouldn't do that, but it's there for you if you would like. Now we also have set initial velocity, which is going to completely override our initial velocity. If I go ahead and set all of these to 0 and not skip any, and I press play, you can see that we have no velocity being added. If I set this to a value of 1, you can see that this is going to add in some velocity for us. So we have basically the same thing. So we can give ourselves an initial velocity either on the the geometry level, or we can do it directly in here. And we have a lot of different options for how we can do it on the geometry level. So let's go ahead and set this back to use inherited velocity. And we can take a look at some other ones. So as we looked at, we have this point velocity, which is going to allow us to add some using this curl noise, or we have the conical noise if we wanted to use that. But we have a bunch of other noises that we can use inside of Houdini. So let's jump down a point up and take a look at this. If I jump in here, we can take our position and we type in noise. We have all of these different noises that we have available to us. So for example, we could use like a turbulent noise, and we can wire this into our position and our noise into the velocity. So if I come back in here to our popnet, wire this up, if I press play, you can see that we have a noise being applied to it. Now, it's important to note that we have this currently set to a 1D noise, so it's only going to be moving in that particular direction with the values that we have set. If I set this to a 3D noise, we can press play and we start to get something going on here. Now this is, depending on the noise type, it's not going to work in all three directions. Sparse convolution is one of them. If I press play, or sorry, not sparse convolution. Sparse convolution does apply in all three directions, but the Perlin noise is one that does not. So if I press play, you can see that we're only getting that particular direction that is being applied. And again, we can come back to our geometry here and we can visualize this velocity vector, and you can see exactly what we're getting. So again, doesn't matter. You can play around with our frequency. We can play around with the roughness if we wanted to, but it's not going to apply just based on what type of noise it is. If I select the original Portland, you can see that we are now getting velocities in all directions. So depending on what you want to use, you can get some different looks. This is really where things start to really take off in what I consider the fun part of particles, because you can get some really cool looks with these. You can mess around with a lot of different noise types, the roughness, all sorts of different settings to get some awesome looks. So we have these. We also have, like I said, other noise that are available to us. We have, the curl noise here. We have, all these different noises that we can use, and we can take those and bring those into our popnet, and we can apply those to our particles and get these really interesting looking effects. If I can get that to turn off, we get these really interesting looking effects that are going on with our particles. So that is just one way that we can add in some forces to our particles to get some movement. In the next video, we're going to take a look at some other forces like gravity, and we have the pop force and the pop wind and all of those. But I wanted to just focus on how we can bring in our initial velocities, because not only do we use this for pop nets, but we can also use our initial velocities and other things and other simulation types like rigid body simulations as well. So it's important to know how we can bring those in and how we can, use our velocities to drive movement throughout our simulation. So anyways, hopefully this has helped you out. Like I said, this project file will be available on Patreon with some added extra little notes and stuff. So if you want to grab it on there, then you can do that. But otherwise, we're going to be, like I said, taking a look at other ways to affect our particles with forces and such in the next video here. So hopefully this has helped you out. Thank you guys for watching, and have a good day.